If you've ever wanted to have your own weather station, well, today we are talking about one of DIY projects called Solar-Powered Wi-Fi Weather Station version 3.2. We'll start in a couple of seconds. This video has been sponsored by PCBWay, and I really want to thank them for providing me with this kit. By the way, if you need PCB boards, if you need CNC, 3D printing, PCB assembly, or anything PCB or project related, go to PCBWay. In the video description, you will find a link to both PCBWay, this PCB Only purchase for this project, but also a link to this kit. And in the kit, you will receive a sample board, ESP32 board, and a solar panel. This project was sponsored by PCBWay. Once again, they approached me and asked if there is a room for cooperation. And since I was eyeing this project for a long time, I said, sure, why not? So what they did, they sent me the kit. And yes, you can either buy kit or just PCB from PCBWay. If you opt out for PCB, then you will have to source everything you see in this image. These are the sensors, the components that are through the mount components for PCB, batteries, solar panel, ESP32, etc. But as I mentioned, there is also kit version. Just note that kit doesn't include every sensor I will be showing you today. The kit version of this DIY weather station project comes pre-assembled. The PCB itself is pre-assembled. But that's not all what you get. You get the PCB, you get the ESP32 board, and you also receive a solar panel. So I would say you are halfway there. First, let me make something clear. This project is not my DIY project in terms of I designed it, but instead it's made by Open Green Energy, and the original author's name is Debasish Dutta, and I apologize if I butchered your name. But why do I consider this project also partially my project? Because this project has two parts. One part is hardware, and this was done by Open Green Energy. But the second part of the project is the code that runs it. Well, that part is my part. And I really did spend a lot of time making this code work as simple as possible, but also reliable. So, let's have a look at hardware first. This is how weather station when it's assembled looks, and it also has external temperature sensor. So let's open it up and see what's inside. You really have to appreciate nice design because you do not have to screw this mount anywhere, you just need to slide it in. As I mentioned previously, only a couple of things arrive if you order the kit, and that's the solar panel, which is attached here, the ESP module that is here, and the board itself. Let's power it off. Remove the battery just to be on the safe side and detach other modules. To complete the weather station, you have to order something like this, and this is BME280. You can use either BME280 or BMP280. The difference is that the BMP version measures only temperature and pressure, while the BME version also measures the humidity. And if you want to go for something, I would definitely recommend that you go for the BME version. The next thing we have here is the lux sensor. It's BH1750. The lux sensor, of course, is used to detect the lux. If you want to have the lux values in your weather station, you have to buy one of these. The next optional thing that you can buy for this weather station is this DS or Dallas sensor. The Dallas sensor allows you to measure temperature away from the box of weather station. Yes, this is the Stevenson box, meaning that air can flow between the ribs, and it should be a bit cooler than if it would be just a normal shut box, but still the temperature inside can be higher than the air. So that's why I've also attached via this cable this Dallas sensor. And this DAS sensor, it has 1 meter long cable, can then be fixed somewhere in the shade but still near the weather station. Okay, so now we have temperature, humidity, lux and one additional temperature sensor, but what weather station would this be if we didn't have some additional sensors? And that's why we have this anemometer or wind speed sensor. The wind speed sensor and one additional sensor that I still do not have because packages sometimes do get lost, and unfortunately the seller didn't send me both this speed and direction sensor in one box or one package. He split the shipment into two parts and now the second part is lost. But this one combined with the wind direction, and this one is attached or connected directly to wind sensor, and then the wind sensor cable goes here, allow you to detect everything related to the wind. There is unfortunately one negative side about this project and my version of code. Since we want to save the battery, device goes into deep sleep. And in the deep sleep, of course, the sensors do not measure anything. So, if there is a high wind gust while the device is asleep, it will not be detected. But for normal wind, you will have values in your Home Assistant. And yes, even if you do not want to buy the wind direction sensor, you can still hook this up like this, and it will provide you with the values for the wind speed. But we still need one additional sensor. And this is the rain sensor. This one is a bit dirty, but this is also salvaged rain sensor, rain gauge from my old weather station. And I think this one is old at least 5 if not 10 years. So what does it do? It measures the rain. And all you have to do is hook it up. And now you have fully functional working weather station. And by the way, it already is charging the battery, or at least trying to charge the battery since the battery is here. You can see the red light. This red light means that the solar panel is receiving enough light and it started to charge the battery. Let me insert the battery. And let's turn this on. The red LED means that the ESP board is powered up, and if appropriate firmware is already on the ESP32 board, it should start sending the values. And what values? As I mentioned, temperature, humidity, pressure, lux, additional temperature, wind speed, and rain. And now it's time to talk about my baby or the firmware. For this project, at least for my part of this project, I have created a separate GitHub repository. And the link to it will be in the description of the video, and it's called Solar WS or Solar Weather Station. On this GitHub page, you will find all the necessary information in regard to this device and also information about the code. You will have links to original projects, which include the Arduino files from the author. You will find the PCBWay links to PCB Only, assembled PCB, links to all the sensors I used in this device, but you can of course source them from wherever you want. Housing, which is a 3D printer printed housing, and I printed it from the ABS. Yes, sure, you can print it from the PLA, but I wouldn't recommend printing it from PLA since this will be directly in the sun. In the About the Code section, I talk about code. Currently, this code is using Home Assistant API for ESPHome. Of course, it can be easily converted to MQTT, but so far I haven't done that. If there are any requests for that, I will consider it. One of the biggest challenges for this device or any solar power device is the battery life. And this is why we are using deep sleep. But one of the issues with deep sleep that I really hate is the option to use over-the-air updates. I currently am using deep sleep on my Hygro boards that are connected through the ESPHome, and anytime I want to update the firmware, I have to take a cable and flash it directly by using the cable. I didn't want this to be the case with the solar-powered weather station because it's probably somewhere outside and you don't want to carry your notebook and flash the firmware, So I have implemented something that allows you to do the over-the-air updates on your ESPHome device. And I'm really happy about it. What kind of battery powered device this would be if it didn't have battery tracking? There are still some quirks with the data that is reported or sometimes misreported or unreported to Home Assistant, but overall it's working great. I did mention that I'm using BME, but you can also opt out and use BMP sensor. If you are using BMP sensor, you will have to comment out this section of the code because the BMP sensor doesn't provide you with the values for humidity. DELA sensor is additional sensor that is used to track the temperature. But in order for you to have DALA sensor work, there are two steps. In first steps, which is already included in the code, you have to specify this. When the board then reboots, it will give you the address of the DALA sensor. Then you have to change in this part of the code address and specify the address that the board reported. Rain sensor is a simple pulse counter. But please be warned that this counter only works when the board is awake. I'm still looking into implementing additional code that would also track it while it's asleep, but this will have impact on a battery life. The lux sensor gives you values for the lux. Wind speed sensor is again a pulse sensor, and it is used to track how fast it is spinning and from that calculate the wind speed. I still have a couple of things to tweak and work on, and these will always be listed in the to-do section of the GitHub. If you yourself find something that can be improved, please make a commit and I will try to include it in the ESPHome code that is included here. But besides README, there are two additional files. We have sample log, which is a log output of my device, and you can see here how you should receive or read values from your device. I did mention previously the Dallas address, and when you first boot up, it should show you something like this: Dallas component, pin, update interval, and what sensors have been found. This is the address you have to copy. And of course, the third and the last file included in the repository, for now at least, is the code itself. The code has two sections. First section is substitutions, and normally you shouldn't need to change anything besides that. If you do change something, it means that you improved on something, and I really would like to have feedback. So if you improve on something, please create an issue and say what you changed and submit the code, so I can include it here in the repository. Okay, now let's prepare the firmware. For this part, of course, you will need to have ESPHome installed. You need to have this ESP32 board that you either got with the kit or you separately purchased, and of course the USB cable. Connect your device to the PC, click on New Device, give device a name. In the network name, type the name of your Wi-Fi network, and of course the password. Click on Next. We will not be using Connect, we will skip this step. The board itself is ESP32, and we will skip it. This is our new device in the ESPHome. Let's click on Edit. We will delete everything we have here. In the repository, you can either download the file or go to RAW, press Ctrl A, Ctrl C to copy, and back inside ESPHome, just paste the code here. If you want to change something, you can change the display name, and this display name is used to create entity names inside Home Assistant. We are substituting everything with this solar WS. So for example, pressure is called solar WS pressure, humidity is solar WS humidity, etc. Awake duration specifies how long the device will be awake before it goes to deep sleep. It is currently at 30 seconds, and for now at least I would recommend that you stick to this value, because it has impact down in the code on other values. Sleep duration is how long the device should sleep before waking up and sending new values. The default value, at least here, is 5 minutes. I wouldn't go below that, but you can increase the time. For example, my previous lacrosse weather station, I used it to report values every 12 minutes. And by using 12 minutes, I get 5 data points in 1 hour. Battery full and battery empty are values that are reported by this device when either the battery is completely full or while the device stops responding and sending data. These values you will have to track and find out yourself for your device. For me, these two are my values. And we also need the difference between those two battery values because we need it later on to calculate the percentage of the battery full state. Other values or other code below this line you do not have to touch. Everything should work out of box. I did mention previously, if you are using BMP version, just comment out or delete this part of the code. When you are ready to install code, press on install, plug into this computer, select the port where the device is plugged. For me, this is COM port 12. Make sure that the device is plugged in. If you do not see the device in the list, you need to install the drivers. Select the port, connect, and the system will now prepare the firmware, and when it's ready, it will flash it. And the flashing of the firmware is done. Close. You should also now see notification that the new device has been discovered. There are still two things we need to do to complete this project. And for one of them, we have to go back to code and copy one line. Click on Edit and find this part here. We have to create in Home Assistant input boolean or helper called SolarWS prevent deep sleep. I will copy this here. Close, automations and scenes, helpers, and create new helper. We will create toggle, and it will be called SolarWS prevent deep sleep. This name has to match the name inside the ESPHome code, so if you give it any other name, don't forget to change it in the ESPHome code too. Let's add icon and create. We now have input boolean, and this is the same name that is in the ESPHome. And the last step is to add solar weather station. Don't forget, you have to unplug this and insert it in the board itself. When you are inserting it, just be careful of the orientation. This part here, which is antenna, goes towards the battery, and the connector, USB connector, goes towards the edge of the board. Click on Configure. Submit. And here comes the first problem with any sleep devices. If the device itself is not awake at the time you try to add it, you will fail. If you time it right and press submit at the right time, it should add the device. And device is added. Let's press finish. Let's check here. So we have solar weather, one device with 10 entities. We have rainfall, which is 0. We have air temperature. This is the Dallas sensor, battery percentage and battery value, humidity, lux, pressure, weather station temperature, which is the BME value, and the wind speed. Let's add it to Lovelace. Fun stuff. Next. Add to Lovelace UI. In order for you to make it easier to do over-the-air updates, I would recommend that you edit the dashboard, edit, and add here the input boolean. Save. Let's see what is the procedure to do over-the-air updates. So if you want to flash the new firmware, first thing that you have to do is flip this switch. Prevent solar weather station deep sleep. Next time, when the weather station wakes up, it will detect the state of the switch and it will prevent it to go from sleeping. Next, go to ESPHome. On the Solar Weather tab, click on 3 dots, Install wirelessly, and we will precompile the firmware, because we want to shorten the time needed for the device to be updated. And device is still not up. Let's press on retry, and we will keep pressing it until the firmware is updated. As you can see, the firmware is now being uploaded to the ESP32 board. The switch should now also be automatically flipped to off. Let's see the data. So the data is here. The state has been set to off. It is sending all the data. If you don't see this warning that it has been disconnected, press on stop, go to overview, and just check if the input boolean switch has been turned automatically to state off or not. And that's it. Let's briefly talk about the project. First of all, I really like it because it has 5 things that I really like in any project. It has 3D printing, it has a bit of soldering, it has ESPHome code, it can be added to the Home Assistant, and it is using solar and battery power. So these are the 5 things that are all combined in this project. How accurate it is? Well, all of the sensors here can be tweaked and calibrated. So if you have any issue with any of the sensors, you can play with the calibration points and calibrate it to your own needs or likes. As I said, I will be working more on the code and try to improve it. I will also try to make as accurate as possible the wind measurement and rain measurement. And if you see update to the ESPHome code, you can see what are the changes, and if you decide to go for those changes, you can just replace part of the code or all code and flash it, and that's it. Once again, I really would like to thank PCBWay for sponsoring this video and allowing me to play with this technology. And I really would like also to thank everybody who is supporting me on the YouTube and has become my YouTube channel member. Thank you all for all of your support. You are making it much more easier for me to play with fun stuff. But also I would like to thank everybody who has subscribed, watched or liked my videos. Thank you. If you too want to support the channel, you can do so by clicking the join button down below. If you have any kind of a comment or a question in regard to this project, you can go to GitHub, you can visit the Discord server, and the link to Discord server is also in the description of the video, or feel free to leave comment down in a comment section below. If you did like this video and did find it useful, at least for bits and parts of the code that you can now reuse for your own projects, don't forget to give this video a like. It means not just a lot to me, but it also helps with the YouTube algorithms. If you still haven't subscribed, please subscribe and hit the bell button so you get notified on the future video releases and of course the streams. And hopefully on the 2nd of April there will be a stream and we will be working together on the ESPHome project live. Not this one, the new one. And I'll be seeing you next time. Until then, bye bye and have fun.